We're going to continue and look at what is fair test. So fair test, basically, it is involved, or what you want to know is that fair test talks about the fact that there is only one change variable and nothing else. So like how I've explained to you previously, for fair test, right, you need to understand why when certain variable is maintained the constant, how does it affect or not affect an experiment. Okay? So basically, what you have here over this part is we're actually looking at how you can model when answering a fair test question. So when you want to say that yes, it's a fair test, okay, there is only one change variable, which is what, and what was kept the same. And when you want to talk about no, how can you then answer? Okay? And then you talk about what is the difference. So let's take a look at a question to understand better. So, question 14. Clarice carried out an experiment to find out which material reflects light best. She prepared the setup as shown below using materials A, B, and C. So basically, your materials over here would be your change variable, right? And everything else needs to remain constant. Okay? So explain why Clarice, okay, conducted her experiment in a cardboard box. Now, I always tell my student this. You cannot just say, oh, this is to ensure there's only one change variable and hence it's a fair test. No, that's too general. Instead, I want my students to always ask yourself, what is the alternative? Meaning, what's the opposite? So what will happen if, let's just say, you do not conduct the experiment in a cardboard box, you do it in the open, what will happen? So when you ask yourself this kind of question, the opposite question, it sort of forces you to realize that, your light sensor, when it's inside the box, only detects light that is reflected from your material, right? But if you were to not use it in the cardboard box, you will be detecting light from elsewhere, okay? From the surrounding light and whatnot. Correct or not? So when you think about it, one way is to ask the opposite question, okay? So what happens, okay, if not? I always ask myself this question. So with that in mind, okay, you would then be able to answer the question. So how does it look like? Okay, it is to ensure that the amount of light detected by the light sensor is only due to the type of material and not from the surrounding and not from other variables like surrounding light. So let's take a look at this answer. So in order to craft this answer, you realize that this is exactly what I've been telling you earlier, which is to ask the opposite question. What happens if you do not conduct this experiment in a cardboard? You realize that, then you will detect light from elsewhere. So you want to actually make sure that you are able to write that down. So the amount of light detected in this case is your MV And then after that, your type of material is your CV. Okay? So because of this, you will make this a fair test. Okay? If not, then you think about it, your data logger or your light sensor, the amount of light is not from, may not be directly from the material that reflects the light, but from your surrounding. Okay? Or there is a simpler answer, but I prefer the first one because the first one really fully explains it all. The second one would be, it is to ensure that the surrounding light does not affect the results of the experiment. So whether you pick the first answer or the second answer, what you realize is that you cannot just say, oh, so that is a fair test. You must tell me what does the cardboard, how does the cardboard makes it a fair test. It basically prevents the surrounding light from being detected and affecting the results. Okay? That's the commonality. Okay, question 15. Gary wanted to find out if the number of leaves in the plant has affected its growth. So this straight off the top is your change variable. He used two similar plants A and B. A had all its leaves while B had most of its leaves removed. He watered the two plants daily the same amount of water and placed them next to each other in the garden as shown below. Okay, do you think Gary's experiment is a fair one? Explain your answer. So basically, in a fair experiment, there should be only one variable, and you need to keep that one. You need to specify that one variable. Okay. So you will answer yes. There is only one change variable which is the number of leaves while keeping other variables constant. Constant means the same. Okay? Now, then after that, you also need to understand one thing. When you talk about variables, right, you cannot just say the variable. You must always give me the quantifying term. So for example, volume of water in the beaker, right? Number of leaves. Because you cannot just say leaf, oh, the leaf must be the same. But there are many things about the leaf, you know. There can be type of leaves, they can be mass of leaves, size of leaves, color of leaves, number of leaves. So you cannot just say, oh, the leaves must be the same. Or you cannot just say the water must be the same. Temperature of water, volume of water, okay? So all these things need to be quantified. Okay, we will go on to take a look. Okay, now question 16. Henna put two pieces of cake into two identical jars, A and B, and added a few drops of water to the cake in jar A. So basically, this is the change variable. If you're quick to spot, because one has water, the other does not. She ensured that the jars were airtight sealed so that no air could enter the jars. The diagram below shows the results of the experiment after 3 days. Okay, so explain why Henna has to use an airtight container to ensure a fair test. Now, this is the case, alright, whereby we need to be a little bit what do you call? You need to relate to what you've already learned. So some keywords that we think of, moldy and non-moldy. So if I'm going to look at this, right, I'm teaching you how to actually narrow down your answers. When it comes to mold, think about the factors that causes mold to grow, right? You would have your warmth, you will need your moisture, and your oxygen, right? So these are the factors that, or air, that you need to grow, okay? So then they ask you, how come you use an airtight container? So the change variable here is your water. So think about it, water and airtight. Okay, so basically an airtight prevents a change in the variation of the composition of the air, right? So it is to actually ensure that air does not change at all, making it a fair experiment. And the one with water should be the one that is moldy, which is what is true, correct? Because jar B is the one jar A is the one with water, which is consistent. So why? This is to ensure. So remember I told you what is the opposite, right? So if she doesn't use an airtight jar, what will happen? The composition of air will differ. So then flip it back around. This is to ensure that the amount / composition of gases in the containers is the same. Hence, there is only one changed variable, which is the presence of water on each cake. So that the experiments are test. Okay, so in this case we can say presence of water because presence can mean presence or or absence, that's it. Okay, moving on. Question 17. Gopal wanted to find out how material X affects the way cold water gains heat. Okay, diagram below show two set up. So the change variable will be 1. This is the change variable. Okay, and what is the measured variable? Measured variable would be temperature. They didn't say that, but it can be inferred, right? Okay, so is the experiment a fair test? Explain your answer. So in this case, I would say that it is not a fair test. Why? Because besides the presence and absence of material X, you have one more variable, and that is the fact that the volume of water is different. Okay? So your answer would be no. In a fair test, there should be only one change variable. Which is the presence of material X. While keeping the rest of the variables like such as the size of the beaker constant. Okay. However, in this experiment, so what was it that it was different? The size of the beaker and the volume of water were different for both setups. Okay, so because of that, there is more than one change variable. There is like multiple change variables. So suggest two changes to make it a fair test. So basically, it's to make it the same, right? So basically, you either change the big beaker to both big, or rather, sorry, you change the big beaker to small beaker, or you change the small beaker to big beaker. Okay? So you can have the first one would be to change the large beaker to a small beaker. The second one would be to change 150 ml of water to 100 ml. The key idea here is to get both sides to be the same. Okay? Alright, moving on. Stephen took 3 identical pieces of paper and made 3 similar planes of different sizes. So this is the change variable. Okay. He had a plane launcher that is able to throw the planes with equal amount of force and direction every time. He used the launcher to throw 3 paper planes and he recorded the time taken for each plane to stay in the air. Okay, so time stay in the air is your measured variable. Okay, and the results, okay, are shown. So whenever you have a results table, it is always good to actually draw an arrow to see if there's a trend, right? So in this case, we cannot straight away draw a trend because you realize that it's 4, 3, and 5. So you may need to do a little rearrangement. Okay? So in this case, the one with the wingspan that is smallest is actually B. So B should go up to here. Then it becomes 3, 4, and 5. And then you will notice, what you notice would be that as the wingspan increases, the time for the plane to stay in the air also increases. Okay, why must Stephen use a plane thrower to throw the paper plane? So remember, I always tell you this. Ask the opposite question. What will happen if he doesn't use a plane thrower? So you will notice that then the force and the direction that the plane will be launched would be different, right? Okay? So it is to ensure that the paper planes were thrown with equal amount of force and direction every time. So that the experiment is a fair test. Okay, so ask yourself, what is the opposite? What if you don't use a plane launcher? Okay, what will be affected? So based on the above results, what can Stephen conclude about the experiment? So you see, even before I reach the question, I already rearranged this. Okay, so I know that as the wingspan increases, okay, the time for the plane to stay in the air increases as well. Okay, as the wingspan of the paper plane increases, the time for the plane to stay in the air increases.